In this video, we'll be looking at what coterminal angles are and the process for finding them. First, let's look at some definitions we will need for evaluating coterminal angles. When you are given the measure of an angle, they're giving you a number that describes how much you've rotated from a starting position, which goes straight to the right on the x-axis, and an ending position, which in this case is a diagonal line going up and right. So the measurement is this 30 degrees, describing how far apart these two lines are from each other. The terminal side is the diagonal line that's connected to the origin. So it's this purple line that's going up and to the right here. It indicates the final position of us starting from the right and rotating 30 degrees to the left. So whenever you have a line pointing in some direction, that's the terminal side. Now, positive angles are measured counterclockwise, starting from the right-hand side. So if they say 30 degrees, that means I started from here, and then I measured an angle 30 degrees going up and to the left. If they give you a negative angle, we actually measure those clockwise, starting from that same position to the right on the unit circle. We don't use negative angles as much, but they can be helpful. So this one is showing a negative 30-degree measurement. Now, this could actually be described in another way. We could still describe its counterclockwise rotation because it's 360 degrees to go all the way around. So if we did 360 and subtracted 30, this would be the same as saying 330 going around the other way. And the last and most important definition for us here is what are coterminal angles? Well, these are angles that have the same terminal side, which means it's multiple ways of describing a diagonal line going in the same direction. For example, right here, I showed that I could call this negative 30 degrees, but it's also the same as positive 330 degrees. So you could rotate a much bigger angle going around counterclockwise than you would going clockwise. But both of these measurements indicate the same diagonal purple line here. So we call these two measurements coterminal angles. Basically, they have just spun around additional times from each other. Our process for finding a coterminal angle, well, if it's in degree or radian mode, it will change a little bit. Basically, they will always differ by an integer multiple of 360 or 2 pi. Now, what this means is it means take an integer like 1, 2, 3, 4, 5, or 6 and multiply that number by 360. So if I add 1 times 360 or 2 times 360 or 3 times 360 or 4 times 360, those are all coterminal angles. They will all be pointing in the same direction. They'll just have a different angle measurement describing that position. The same thing also works for our radian mode measurements. For these, it's an integer multiple of 2 pi. So if you're given an angle in radian mode, then you could add 1 times 2 pi, or 2 times 2 pi, or 3 times 2 pi. It's always an integer times 360 or 2 pi, depending on whether you're in degree or radian mode. So technically, there are an infinite number of coterminal angles for any given angle, because I could keep adding bigger and bigger integers that I multiply by 360. Now, the most important one for us is generally the one between 0 and 360 for degree mode, or 0 and 2 pi for radian mode. So usually, we're interested in finding the one that is specifically between these two values. So if they give you an angle that's too big, then just keep subtracting 360 until you get a number between 0 and 360 degrees. If you get a number that's too small, if it's a negative number, then keep adding 360 until you get a number between 0 and 360, and then stop. The same thing is done for radian measurements. If it's too small, so if you have a negative radian measurement, then add 2 pi. You usually need a common denominator for doing that. And if the angle measurement is too big, like 9 pi, then subtract 2 pi over and over and over again until you get a number between 0 and 2 pi. These aren't the only coterminal angles. These are just the ones we're usually most concerned with. Usually we like to express it as the number between 0 and 360. So for our first example, we're going to do one in degree mode, and we're going to start off with our 70-degree angle. If we want to find a coterminal angle with this, the easiest one to find is just add 360 degrees to it. So adding 360 is one full revolution around the unit circle, so the 70 plus 360 will give us 430 degrees. So this is functionally the same as 70 degrees because of where it ends up facing afterwards, after it's spun around. If we want to find a second coterminal angle, then I can go back to my original number, the 70, and instead of adding 1 times 360, I can add 2 times 360. So any multiple of 360 will give me a coterminal angle if you add or subtract it. Well, 2 times 360 is 720, and the 720 plus 70 is 790. So 70 degrees, 430 degrees, and 790 degrees, they all end up facing in approximately the same direction. They all end up facing basically up and right in the first quadrant. They all end up facing that way. It's just that some of them might have spun around an additional time and then started facing in that direction. Now, if we want to get some negative coterminal angles, it's going to be a very similar process. We'll still start with 70 degrees, but instead of adding 360 to go around once, we're going to subtract 360 this time. So 70 degrees minus 360 degrees will equal negative 290 degrees. And if we want to find another negative angle, we can go back to our original angle. Last time we subtracted 1 times 360. This time I'll subtract 2 times 360. So any multiple of 360 will give us another coterminal angle. So this time we should get negative 650 degrees. Now the radian mode examples can be a little bit trickier because you're often having to add and subtract fractions. So that means you will need a common denominator on these, but the process will be very similar. So our starting angle, we're dealing with pi over 2 for this example. Instead of adding 360 degrees, we want to add that same angle measurement, but in radian mode. So that means we're going to add 2 pi. And if it helps, you might want to think of that as 2 pi over 1. So remember, for adding fractions, since we need a common denominator, you might want to actually think of this as 4 pi over 2. So I'm actually working out 4 pi over 2 plus 1 pi over 2, and that will equal 5 pi over 2. So that's a coterminal angle. If we want to find another one, we can do the same process that we did with degrees. Instead of adding 1 times 2 pi, we can add 2 times 2 pi. So my starting angle is pi over 2. This time I'm going to add 2 times 2 pi, which is 4 pi. If it helps, you can continue to write that over 1. So we need our common denominator. So 4 pi over 1 is the same as 8 pi over 2. 8 pi over 2 plus 1 pi over 2 is 9 pi over 2. So the additional complication here just comes from needing to get a common denominator so that you can add your fractions. If we want to find some negative coterminal angles, instead of adding the 2 pi, we'll be subtracting the 2 pi. So my starting angle is pi over 2. The easiest one to find is to subtract 2 pi over 1. So with our common denominator, if this is 4 pi over 2 instead, 1 pi over 2 minus 4 pi over 2 is negative 3 pi over 2. And for a second negative coterminal angle, back to the original angle, this time I'm going to subtract 2 times 2 pi, so it's a multiple of that 2 pi number. So this is actually equal to 4 pi, but with a common denominator, that would be 8 pi over 2. So 1 pi over 2 minus 8 pi over 2 would be negative 7 pi over 2. And so again, the idea here is that all of these angles, if we drew them on the unit circle, all of these would end up pointing in the exact same direction. Pi over 2 is actually the one that just points straight up. So whether you went from 0 to pi over 2, or whether you went all the way around, pi over 2, pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, you still ended up pointing up in this direction. or around again, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. So you still end up pointing up. So 5 pi over 2, 9 pi over 2, and 1 pi over 2 all point up. Or negative angles just rotate the opposite direction. So negative 1 over 2, negative 2 over 2, negative 3 over 2 still points in the same direction. So all this is doing is showing us that all 4 of these angles actually end up pointing in the same direction as the original one, pi over 2. Generally, when we're looking for coterminal angles, we don't care about having lots of different positive and negative coterminal angles. We actually just care about one coterminal angle. Usually, when I ask you to find a coterminal angle, I want you to find the one that's between 0 and 360 for degree measurement. So let's see what that looks like here. If I give you an angle that's too big, 840 is definitely bigger than 360. So it's too big to be in between these two numbers. If it was too small, it would be a negative number. So when it's too big, subtract 360. If you type this into your calculator, 840 minus 360, you get 480. Now sometimes you may only need to do that process once, but in this case, my number is still not between 0 and 360. It's still too big. 480 is bigger than this. So I need to repeat the process, and you would keep doing this until you get to a number that's between the desired numbers of 0 and 360. So I'm going to subtract another 360. And this time I get 120 degrees. Again, all 3 of these angles are functionally the same, 840, 480, and 120. But the one we usually like to use the most is the smallest one that's between 0 and 360. So this is generally our favorite answer, the one between 0 and 360. The same concept can be applied to radian measurements. We want an angle theta that will be between 0 and 2 pi. Well, right now this angle is negative. So if it's a negative number, that means it's less than 0. So it's too small if we drew this out on a number line. So what I need to do is take that negative 13 pi over 4 and if we want a bigger number, that means we need to add our 2 pi in this case. So I'm adding 2 pi, but I'm going to go ahead and write that with the common denominator. 8 over 4 is equal to 2 pi. So if I add these two numbers together, I get negative 5 pi over 4. Well, since this number is still negative, I know that it's still too small. So I'm going to do this process again. I'm going to take that angle, negative 5 pi over 4, and I'm going to add another 2 pi. But with my common denominator, that's 8 over 4. So negative 5 plus 8 is 3. And now I got the fraction 3/4. Well, 3/4 is between 0 and 2. So if you just ignore the pi for a second, 3/4 is between 0 and 2, which means I do have an angle between the requested values. So all 3 of these are functionally the same. We call them coterminal with each other. But the one we generally like the most is this 3 pi over 4 one. This is the one that we would be able to find on the unit circle. So 3 pi over 4 would be in this quadrant. All of these angles end up pointing in the same direction, but we like to use the one that is easiest to measure and work with. Same thing with 120 degrees. 120 degrees is also up in this second quadrant, but this one's a lot easier to work with rather than measuring 360 around and then doing an additional 120 to end up pointing in this direction. So that's it for coterminal angles. Just always try to find the one between 0 and 360 for degree mode, or between 0 and 2 pi whenever you're working with radians.